Now let's talk about solving logarithmic equations. Logarithmic equations contain the variable within a logarithmic expression. To solve a logarithmic equation, you should rewrite the logarithm as an exponential equation and then solve. So here, the implicit base is 10. This is the argument of the log, and the log is equal to the exponent. So when we rewrite this, it'll be 10 to the exponent, which is 3, equals whatever's inside the log, 9x plus 1. That's how you convert between logarithmic form and exponential form. So now we can just solve. 10 to the third power, that's 10,000, equals 9x plus 1. Subtract 1 from both sides. I get 999 equals 9x. Divide both sides by 9. This cancels with that. The right side is x. The left side is 111. Here, the base is 3. This is the x, and this is the exponent, which is y. So rewriting this, this is 3 to the power 4 equals x. Not too bad. That means x equals 3 to the 4th power, which is 81. So in order to rewrite a logarithmic equation as an exponential equation, you need to have just one log equal to something. So if you have more than one log, you combine them using the techniques we've shown. Here we have the log of x plus the log of x plus 15. By the power property, that's the log, the common log, of x times x plus 15. That's all inside the log equals 2. So if I rewrite this, now that I have it as a log of something equals something, I can rewrite this as an exponential. The base is 10. This is the argument, and this is the exponent. So we get 10 to the exponent 2 equals x times x plus 15. So this is 100 equals x squared plus 15x. We did a whole chapter on how to solve things that look like this. When you're dealing with a quadratic equation, you want to get everything on one side. So I subtract 100. I get 0 equals x squared plus 15x minus 100. I look for, if I can factor, two numbers that multiply to negative 100 that add up to 15. That's going to be 20 and 5. So 20 and 5, and the bigger one is positive. So this gives us that x equals negative 20 or positive 5. When you're dealing with logarithmic equations, you have to make sure that your solutions don't put anything outside the domain of a log. Here, in our original equation, we have the log of x plus the log of x plus 15. And if you plug in the negative 20, in here you have log of negative 20, and you can't plug a negative into a log, so this is an invalid solution. If you plug in the 5, you're okay. Log of 5, and then the log of 5 plus 15, that's the log of 20, so that's okay. So the solution here is x equals 5. So when you're dealing with logarithmic equations, make sure you check your answers. When you have logs on both sides, sometimes it's more convenient, rather than subtracting things from one side and combining everything into one log, simply using the one-to-one property. That is, if you have the log of something equals the log of something else, those arguments are going to be the same. So here I have the natural log of 3x plus 8 equals the natural log of 2x plus 2 plus the natural log of x minus 2. So I can combine the right side into a single log using the product property. This is the natural log of 2x plus 2 times x minus 2. The right side is just the natural log of 3x plus 8. And if you have the natural log of something equals the natural log of something, because the natural log is 1-to-1, or logs are all 1-to-1, this has to equal this. So now I have 3x plus 8 is going to equal 2x plus 2 times x minus 2. And so this is a quadratic we can solve. Here we have 2x times x is 2x squared. 2x times negative 2 is negative 4x. 2 times x is a plus 2x. 2 times negative 2 is a minus 4. Here I'm going to subtract this 3x, subtract this 8 from both sides. So I can get a 0 on one side. That's how we solve quadratics. Now I have 2x squared. I have negative 4x plus 2x, that's negative 2x. Minus 3x, that's negative 5x. Negative 4 minus 8 is negative 12. Here I have 2x squared minus 5x minus 12. We can try to factor this. 2 times negative 12 is negative 24. This center coefficient comes up here. Two numbers that add up to negative 5 that multiply to negative 24. It's going to be negative 8 and positive 3. So we have 2x minus 8, 2x minus plus 3. This is the magic way. Factor out this 2. We get 2 times x minus 4, 2x plus 3. We get rid of this. And so we get, this is x minus 4, 2x plus 3. So the solutions would be x equals 4 and negative 3 halves. You want to make sure you plug these in here to make sure you don't get anything negative. 4, you won't get anything negative in any of these. Negative 3 halves, you're going to have a problem right here. It's going to be 2 times negative 3 halves is going to be negative 3 plus 2. This will be negative 1. So this doesn't work. The solution is just x equals 4.